Assalamu alaikum. My name is Ali Khan, roll number 21TE77. Today we have to discuss the lab number 4 of DSP. So in task A, here is a question. How would you differentiate between signal and a system? Explain the key characteristic of each and provide examples of illustrate their rules and the context of signal processing. The answer is, in signal processing, a signal is a time-varying or spatial-varying quantity that carries information. It can be electrical, acoustic, or optical in nature. A system, on the other hand, is a mechanism that processes the input signal to produce an output. The key characteristics of signal is its information content, while a system is defined by its behavior in transforming or manipulating signals. For example, an audio signal like music is a signal. A speaker or amplifier represents a system that processes this signal to produce sound. Now task B. Question: how does linear time-invariant system play a crucial role in digital signal processing? Considering their mathematical simplicity, adherence to the superposition principle, and efficiency in frequency response analysis. Answer: linear time-invariant systems are fundamental in digital signal processing due to their mathematical simplicity, adherence to the superposition principle, and efficiency in frequency response analysis. These systems exhibit consistent behavior over time and possess linear and shift invariant properties, allowing for straightforward mathematical representation. The superposition principle enables the analysis of complex signals by decomposing them into simpler components. Additionally, Additionally, their frequency response analysis is efficient, providing insights into how the system responds to different frequencies, crucial for designing and understanding digital filter and DSP. Now task number C. Question: what are the common methods for signal decomposition, specifically focusing on techniques like impulse decomposition, step function analysis, even art decomposition, and feature analysis? Explore how these methods contribute to breaking down signal to their applications and signal processing. Answer: common methods for signal decomposition include impulse decomposition, step function analysis, even art decomposition, and Fourier analysis. Impulse decomposition involves expressing signal as a sum of scaled and time-shifted impulses. Step Step functions analysis breaks down signal based on their step responses. Even odd decomposition separates signal into even and odd components. Analysis decomposes signal into a sum of sinusoidal components, revealing their frequency content. These methods play a crucial role in signal processing, allowing for better understanding of signal characteristics and facilitating the design of filters and other processing techniques. Now task D. Question: what is convolution and how does it play a significant role in digital signal processing system? Explore the fundamental concept of convolution and elaborate on its importance in various DSP applications, such as filtering signal processing, and system analysis. Answer: convolution is a mathematical operation that combines two signals to produce a third, representing the integral of pointwise multiplication of the input signals. In digital signal processing, convolution plays a crucial role in applications such as filtering, signal processing, and system analysis. It is fundamental for understanding how signals interact with system, enabling enabling tasks like convolutional filtering to extract specific features or analyze the response of system to input signal, making it a cornerstone in various DSP algorithms and applications. Now task C question. When, when do we correlate two signal and what are the key applications or scenario where signals correlation is crucial in various fields such as communication system, radar and sonar images processing, biomedical signal processing, control system, wireless communication and seismic signal processing. Answer: we correlate two signals when we want to measure the similarity between them or identify patterns of interest. Signal correlation is crucial in communication system for demodulation and error detection, radar and sonar for target identification, image processing for pattern recognition, biomedical signal processing for event detection, control system for feedback analysis, wireless communication for channel estimation, and seismic signal processing for identifying surfaces, subsurface structure. Correlation is a fundamental tool across various fields, aiding in tasks that involve matching or comparing signal for meaningful analysis and decision making. Now we move toward the task number 1. So here in task 1 we define a function that is convolution graph. Then we take a signal hx from some user and also take a signal h from some user h. Then we convolve both these signal x and h. Then we use figure command for providing figure. Then use subplot 311. Then use stem for providing x, then use title input signal, then subplot 3 1 2, then stem for providing h signal, then use title, then again use subplot 3 1 3, and then use stem for providing convolution of both x and h, and last we give the title output signal and then end. The output signal is like this. This is input signal X and this is input signal H. When we convolve, so this is the output signal. Now we move to the task number 2. Here in task number 2, in this task we add T start which is the combination of T1 and T2, then produce Tn, then we find difference between T1 and T2, then using for loop from N1 to length h, then we use figure, then stem command, then use x label for labeling in x axis, then use y label for labeling in y axis, then use title, then use axis, then use third, and then use use command. Again we define input signal, that is T1 range from -1 to 1, then use exponential define T2, and in last we convolve both these signal by using flip and slide method. At the end we get output like this. In few seconds we get all these samples like this. Now we move toward the task number 3. So in task number 3, first we define a convolution, then define NYB, NYE, and NY. And in Y we convolve X and H. Now we define a range of X, then define a range of NX, then define a range of N, then define range of NH, and N last we convolve N, NX, H, NH, and use stem command, and in last we give title. As a result we get an output like this. Now we move to the task number 4. This is the last task, and in this task first we define H, then define X, then in Y we convolve both these X and H, then use subplot, then title, then again use subplot, then give the stem command to define H, and then give title again, then again use subplot, and again use stem for define y, give title, give x shifted, y shifted, use figure, then use stem, use title to shifted input signal, again use subplot, and again use stem command, then y shifted, give title. As a result we get an output like this. All these tasks about the lab number 4 of DSP. So thanks for watching.